Welcome to the SQL Server Fast Execution Plan video training presented by Hugo Cornelis. The advanced level of Block 3 continues coverage of join operators where the basic level stopped by showing how the algorithms can be adapted to execute all supported logical join operations. We also cover various advanced topics for each join operator. In Chapter 1 on nested loops, we look at how the results of a join must change as the join type changes and then adapt the flowchart of the inner join to ensure that those different results are indeed returned. But the actual operator does of course not have separate logic for each join type. So in the end, we combine the flowcharts for each individual join type into a single flowchart for all supported join types. After that, we take a look at how the optimizer works around the limited set of supported join types for the nested loops. We conclude the chapter with a look at various optimizations for nested loops, such as ordered and unordered prefetching and the so-called optimized nested loops. The second chapter, with advanced topics for merge join, once more looks at how the logic can be adapted for each different join type. Again, by looking at flowcharts for each join type first and then combining all the changes into a single flowchart that actually represents the logic of the operator. After that, we show how the basic algorithm fails when there is a many-to-many relationship between the inputs and how SQL Server works around that. That workaround is not free though. We end the chapter with a look at an edge case where merge join is used to produce the Cartesian product of two inputs. The hash match operator is covered in Chapter 3. Both the build phase and the probe phase need to be modified a bit to add support for other logical operations. In some cases, we even need to use a third phase called the final phase. For each of these three phases, we show flowcharts to support each join type and then combine these to show the actual operator logic. Once that is done, we move on to memory usage of the hash match operator. Because the allocated memory is based on estimates, it might be insufficient. In that case, the operator has to spill to TempDB. We show in detail what happens internally when a hash match spills. The chapter concludes with an explanation of memory management in larger plans with multiple memory consumers and with a short explanation of hash teams. The fourth and last chapter covers advanced topics for the adaptive join operator. Because this operator combines the hash match and nested loops algorithms that we already described in detail in the previous chapters, we now immediately jump to the combined flowcharts for all supported logical operations, because they are more or less the same as the flowcharts for the hash match and nested loops operators. Since adaptive join typically runs in batch mode, we also show how that affects the logic of these flowcharts. Just as a hash match, an adaptive join may run out of memory, in which case it has to spill. When this happens, the operator never chooses the nested loops algorithm, even when the number of rows indicates it should. The last part of this chapter is devoted to a discussion on the types of execution plans that would benefit from an adaptive join. Sadly, the optimizer currently is rather limited. It only actually chooses the adaptive join in the most basic cases and not in more complex situations that would also benefit from this operator. The total level is 3 hours and 20 minutes, distributed across 3 extra long and 1 standard length chapters. Those, of course, cover way more than only the things I just showed. To see it all, please check out the SQL Server Execution Plan video training, Block 3 Combining Data, Advanced Level.